Welcome to another PICkit Plus demonstration and introduction to PICkitAutoWatch. PICkitAutoWatch is a new application, new user interface, a piece of software we're releasing at the moment, and it has some unique selling points that will make it quite attractive to a wide range of people. So what is PICkitAutoWatch? It's a simple programmer for microchip PICs. It's based upon the core that we've developed over the last year, and now it's a very simple interface for nearly 1,000 of the microchip controllers, and basically you just point and click. Okay. It is simple to use with other IDEs, and that's what I'll be showing you today. And I've cut the compilers. You just select the programmer, you select your source file, and set a few parameters, and away you go. It's very, very simple. It does some auto recovery, which means that if you delete files or delete file structures, the software will still survive that, so you can do tidying up. And you've got logging, so you can see what's happening. You could minimize that or make it a bit verbose. Okay. As I said before, it's minimal user interface, simple to use. You can have it on top all the time whilst it's operating. But the key thing is, and it goes back to a key principle of ours, is that it supports PICkit2 and the PICKit3 program out of the box. This can be one of the simplest ways and the most optimized way to leverage your PICkit2 and PICKit3 investment whilst being able to program a few thousand chips. Okay. So I said that it simplifies and automates that programming process. Select your program and away you go. So it doesn't need integration with an IDE. It's very simple to use in terms of you select the hex and away you go. It handles all the cleaning up of folder structures, and it should work with most IDEs. So I'm going to take you through a number of tool chains in this video. I've got a very simple configuration of a 16F chip, a couple of LEDs in a pot just to show you what's going on. I'm using that to show you the LEDs changing as we're compiling, and I'm going to go through a whole series of tool chains to show you how we use it. Okay. So with that, let me just bring up the software and we'll get started. And so here's the application. It's extremely simple user interface. I've got a couple of programmers, so let's get started. I'm going to select a programmer, and the program I'm going to be using is a PICkit3, so I better plug my PICkit3 in. I've got a PICkit2 plugged in at the moment from so I'll just bring that up. There we go, PICkit3 is ready. I could use PICkit2, and I'm going to select some source files very shortly. I'm going to select my device, and at my device I can just type in the minimal information I know. I will be providing power to it. I'm going to leave the power on, and I'm going to leave it programming all these different areas. And as I said before, you can have it stay on top of the program. So let me just pick a program that I've obviously been compiling. This one here will do, because I just want to show you the camera so we can see exactly what's happening on the screen here. So if I run that, this is a single write of the operation, and it's just verifying things. You can see that I've got a PICkit here. That's an oscilloscope showing the signal coming out from that chip that we've just programmed, and then it's just operating. And then I've got some LEDs here, and trust me, that is connected up to a 16F. There is no trickery. So what we're going to do, we're going to reprogram that quite quickly just to show you that it's very simple to integrate this with different programming tools and tool chains. And so all we're going to do is change the source, and whenever that source changes, we get a program event and it will program. So let me just start with something nice and easy. I'm going to start with MPLAB-X itself, always on top. So it's always there, and basically what I've got is a program here, and it is the same program that I was just loaded, and that one came from somewhere else. So I'll just compile it up. Okay, and what I'm going to do, once it's compiled, I'm going to take the file name and I'm going to put it inside of AutoWatch, and once it's done that, then I'm going to just recompile and play with it. Okay, and we can just see how easy it is to use. So I've got my file name here. Let's have a look. I just want that to the last /. I'm going to browse to find that source file, press that in there, and here it's just been compiled at 1902, so that's definitely my file. I am going to just start that, and it will start now to automatically program upon the change of that file. Okay, so if I just change some of the LEDs, so that, and this is just the source file in the IDE, it will just quickly recompile and automatically program, and you'll see that one more LED has come on because I have changed the code. So if I just change this code, I know it's very simplistic changes, but it's representative of the complexity and of how you can do this. You can clean, you can use all these different features inside of here. You can clean the project. Just for the, if you don't know, other tools will just fall over at this point because the folder structure has been deleted. So I can simply move and program in the IDE, and magic happens by programming it. Very simple, and all I did was take the file name and put it in there. Now you can do this with our other programmers, but they're not as robust, and they will stop working because the file structure has been deleted. So we can integrate into MPLAB-X. What about some of the older tools? Okay, let's have a look at MPASM. Okay, we'll look at MPASM-X. Okay, MPASM-X, let's get rid of that. We'll pull that over. I've got MPASM-X, and I've got a source set of hex files that I've got running here. Okay, so for those who don't know, this is MPASM-X, and here is a source ASM file. Okay, so I'm just going to bring up that ASM file for us so we can have a look. I'll put that over here for us so we can see it, and it is an ASM file for the same chip. Okay, and I'm going to comment out some of the LEDs in here, and then we're going to comment it up. We should only have one. We will only end up with one LED running here at this rate, but it doesn't really matter. And trust me, that source file there, I'll just take a copy of that file name, copy the full path. I'm going to put it inside of here, which is the user interface for MPASM-X, and I'm just going to assemble that. Now, the event that's going to occur won't kick off inside of the software here, because that's pointing at another hex file. So what I'm going to do is just stop that for a moment. That has successfully compiled, and I'm just going to pick up my new file here. Let me just paste it into here, put my hex file in there, and I'm going to start. Now I'm looking at a different program. I'm looking at a source program that is in ASM, so I can play with my LEDs. I can save it. I'm going to then recompile that inside of MPASM-X, which is very simple. And what we're going to do in a moment is just recompile that, and you'll see the LEDs change. Look, because AutoWatch is now looking for that change, and magic happens. So you just point it at the hex file, and it will do the rest for you. Okay. So we've just seen MPASM-X there. Well, what about some other tool chains like non-microchips? How about GPASM? GPASM is quite good, and I'm going to take the same source file here, and I'm just going to have two LEDs. I'm going to have the top one and the bottom one live. I'm going to take the same hex file, and I've got two LEDs running. So I can use any of the tool chains and compilers to generate and program this chip, because AutoWatch is looking for changes in the files. Okay, we're going to go somewhere else very quickly just to show you what it can support. I'm going to take you to a browser, and I'm going to open up MPLAB Express. So MPLAB-X is the cloud version of the toolchain from Microchip, and I'm going to be using a very similar program to control these LEDs. I've just reset my scope there. So I'm going to very quickly show you how I can make that work by stopping this, and then we'll come and change that source file after we've downloaded it. So this tool chain here essentially is a cloud-based tool, and I'm going to just quickly press that icon there and it will download me a source program, and that source program has come to my download folder, and I'm going to point AutoWatch at that download folder, and this is my hex file. I'm just going to open that up, and I'm just going to test to make sure it works, and by running it once, and I should get I should get, let me look at my source, or 1 LED, and then I'm going to press start because that just worked. So I'm now going to make some changes in the cloud, and I haven't got the Java engine. I don't need all those complex pieces of software to make this work. I can simply point AutoWatch at this, and this will very soon support express boards as well. So you'll be able to download that file and put it straight into your chip. So I'm going to make a change up here in the cloud version. I'm going to turn on 3 LEDs. I'm going to make that and then download it automatically, and AutoWatch picks that file up, and I've got 3 LED operational. So if I want to revert my little old program to 4 LEDs, which is where I started, I simply I'll do it slowly, make and program. It downloads it. Now I have got a small tool in my browser that enables me to have a consistent file name, and that is free. That's not a problem. You just install that, and you can see that's the same program that I started with. So I've got the same program. Now you can do this across 18Fs, 10Fs, 12Fs, 16s, etc., depending on what you want. And so my goal here was to show you a new piece of software called PICkitAutoWatch. Supports PICkit2s and PICKit3s, and it's a very simple tool for programming, automatically managing that programming process during your development life cycle. So with that, I'll call it a wrap.